So now we're going to look at comparing expected versus observed frequencies across experiments. We have to understand these two terms first of all. So our expected is our theoretical. What are you expecting to get from rolling it out? We can do that on the board in a moment. Our observed, though, we have to actually do the experiment to collect our data to work out what the frequency is. Okay, so theoretical, if you like, experimental. Okay, and those terms will come up as you get into high school. For now, though, we've got a spinner. There's a spinner game that you guys will get to play later, and it has 5 outcomes. Okay, 1, 2, 3, 4, and 5. And because we have 5 outcomes, we do 5 divided by 100. We know that for every outcome, we have a 20%, 0.2, or 1 in 5 chance of getting. So our outcomes are 1, 2, 3, 4, and 5. Okay, there are possible outcomes. When we actually do it, however, and I've done it on my computer already, so I can just write down the results. So I did 20 spins, because you can set how many you want to do. I didn't want to do too many, okay, but I just wanted to see what I would get. And I actually got, for 1, I got 7, for 2, I got 4, for 3, just checking over there, make sure I get my data right. I got 3, for 4, I got 4, and for 5, I got 2. Now let's just double check that's what my data says, that we actually have 20. 7 and 4 is 11, and 3 is 14, and 4 is 18, and 2 is 20. Yeah, so we've got that there. Now, this is going to give us different results than that did, and that's okay. Okay, so for 1, so the probability of 1 was 7 out of 20. 7 is a prime number, so we can't simplify. So let's just write them all out of 20 to start with. A probability of 2 is 4 out of 20. A probability of 3 is 3 out of 20. A probability of 4 is 4 out of 20. A probability of 5 is 2 out of 20. We know some of these can be simplified. So they can be simplified to 2 out of 10 or 1 out of 5. Same as that one. That one, 1 out of 10. These two are prime numbers, they can't be simplified. So, what does this data tell us? Compared to our theoretical of 1/5, it tells us that 2 of those were exactly the theoretical outcome. It also tells us that 1 of these occurred way more times than it should have, theoretically. Okay. 1 occurred half as much as it should, and 1 occurred 3/4 or 3/4 of the way to where it should have been at. So this one's fairly close, so theoretically you would give that a tick as well. Now, we don't need to explain why that happened because it's random. Okay, the spinner had 5 even parts, random generated spins, so it's not like you've stacked it or it's been unfair or biased. Okay, but we need to be able to identify this particular thing that we just spoke about, that these 3 here are close to the theoretical or expected frequencies. This one's twice as far out and this one's a long way out. So if we were talking in terms of our data, we would call that an outlier. Okay, an outlier is something that stands out away from the trend of data, doesn't really fit into what it should be expected to